The idea of having this video is to show you how to model a box girder bridge using SAP2000 software. So before moving on to the model, there are a few things that you should know. If you consider a single eye girder section, it will give you a very low torsional capacity. So the idea of going for a box girder bridge is to have a high torsional capacity due to its enclosed nature. So using eye girders, we can establish a closed section that will give a very high torsional capacity in a box girder bridge. So ideally, we will have two eye girders on either side, and then two rectangular beams. And to connect this eye girder and the rectangular beam, we can have a transverse top beam on either side again. And this area between the two eye girders, again we can have another set of transverse beam. So we can define an eye beam, but ideally with a web thickness that is 0 or somewhat that is almost closer to 0. So that way we can establish an enclosed section for a box girder that will by having this shear flow inside this enclosed section, it will resist or ensure that there won't be any torsional deformation. So to ensure this, we have to define the torsional constant in the system. To that, we can use this equation here to calculate the torsional constant, and that we can manually input this into our model in SAP2000. So if you know the parameters T3, T2, T1, and the area enclosed by the section, and also the B and D values, the breadth and depth, you can calculate the shear flow integration using this equation. And since you know the area, you can easily calculate the torsional constant. And when we move on to the model, what we do here is essentially a grillage analysis. So we will have, if you look from the top, we will have two rectangular beams on either side, and then the main eye girders. And to ensure the node connectivity and to ensure the convenience of applying loads, we will have two sets of transverse beams. One will be this transverse beam connecting the rectangular beam and the eye girder on either side, and then in the middle we will have another set of transverse beams. Those are the eye beams with almost 0 web thickness. And whatever the torsional constant that we calculate here, that we will assign half of that value to each eye girder in the system, so that we are ensuring that we have an enclosed section with a high torsional capacity when performing our analysis. So let's move on to see how to do this model in SAP2000. So in SAP2000, the first step would be to define your grid. So if I quickly define my grid, all the transverse beams and the longitudinal beams will be spaced at a distance of 1 meter. So, and also I would assume that the eye girder is of 1.8 meters of height. So that way I can simply define my grid. And then if I define the concrete, we can easily define a concrete, let's say grade 40. So I have my concrete, and then if we define the sections, so first I will define the rectangular beams that we have on either side. So that would be grade 40, and then I can define the eye girder, eye beam, And the important point here is that in set modifiers, you have to set the torsional constant. If it is a single I-Girder section, then ideally you should model this as a torsionless system. So this value, you cannot enter 0, that will lead to error. So you can input some value that is almost 0. But in here, we are trying to establish an enclosed section, so the torsional, so we have to manually calculate torsional constant from the equation that I showed you earlier. So for this system, I have calculated the torsional constant as 34.5. So we have two I-girders, so half of this value should be assigned to each I-girder. So in this case, I will assign half of this value and set it. And then you can again have the transverse top beam. So these beams will be at 1 meter spacing, so I will have the width as 1 meter with a thickness of 250 millimeters. And the next important point is to have that I-beam in the middle, which is again an I-beam. I would say so again so the values that we're going to enter, again we have in 1 meter spacing, and the bed thickness, this value should be as small as possible. Something like this. And now, since we have the sections defined, now we can create our model. So we have the I-beams. And then the rectangular beams on either side. And then you can have the transverse top beams. Then you have again the I-beams in the middle. And then so this is so we have the longitudinal beams, the girders, and the rectangular beams, and then we have the transverse beams in the other direction. So the main idea of having these transverse beams is the convenience of applying our loads, and also in a grillage analysis we have to ensure the node connectivity between the transverse system and the longitudinal system, so that using the transverse beam we can easily apply our loads, and then we can easily transfer that load onto our I-girders. So always we have to ensure the node connectivity between the transverse and the longitudinal beams. And the next main point is the support conditions. So usually in a bridge, we know that there will be thermal contractions and expansions. So we have to allow some movement in the horizontal direction in a bridge. If not, it will impose additional compressive stresses on the bridge that can lead to cracks and other issues. So for the support conditions, on one side we can assign pin supports, whereas on the other side we'll have to assign roller support, so that we will be allowing some movement in the horizontal extranslation. And then the other main point is the load application. Ideally, we should consider the dead loads, the live loads that are coming from whatever the carpet of the road and of the pedestrians and all that live loads, and especially the moving loads, where you have to consider the HHB loading and the knife edge loading. So these loadings have to be properly defined through using the load cases and load combinations and all that. But for the sake of demonstrating you how to show you how you get the movements and all that for actions in this beam in this bridge, so I will just define a simple load pattern, a live load, and I will assign that loading onto the beams. So see how easy it is for you to apply the loads onto this, and you can change whatever the loading that you apply whenever you want. We just apply a distributed load. So if I show you, so we are having a uniformly distributed load, and if I quickly define a load combination, let's get the just for you to show, but ideally you should consider all moving loads and everything when you define this. And we do not need the model run right now. So if you run this, you will see how you the moment diagram and the shear force diagram. So whatever the torsional moment of this bridge system would be the addition of the torsional moment on these two eye girders, and whatever the bending moment that you get in this bridge system, in this bridge, will be the addition of the bending moments of these two rectangular beams as well as these two eye girders, because this is a single cell box girder, because ideally what we have is a single section, a single box girder section. So whatever the bending moment that you have to consider in this box girder would be the addition of all four bending moments that will be acting on the two rectangular beams as well as the two eye girders. But when it comes to the torsional moment, it will be only the two eye girders that you consider here. So this is about how you model a box girder bridge, and hopefully I will try to have a video on how to apply moving loads, HHB loading, knife edge loading, and how to consider all these load combinations. So this is a simple demonstration of how to model a box girder bridge, just for you to have an idea, because what we essentially do is we try to get the actions, and then we try to choose our section, the section sizes and all that. So this grid edge analysis is something that we use in the preliminary stages of design for you to have an idea about what the sizes of sections that you're going to need. So this is the simple way of doing a analysis for a box girder bridge. So if you have any questions, feel free to ask me. Thank you for watching.